Everything we've stored so far disappears when the program ends. Files got us part of the way, but the moment you want to ask questions of your data, filter it, sort it, count it, you want a database. SQLite is perfect for this. The whole database is one file on disk, there's no server to run, and Kaappi talks to it directly. One package. Like the networking library last episode, it has a small C part that gets compiled when you install. That's it binding to SQLite itself. Call-with-sqlite opens the database, hands it to your function, and closes it afterward, even if something goes wrong. The same shape as the file helpers, and the same idea as Dynamic Wind from Season 1. Give it a file name, and it creates that file if it isn't there. sqlite-exec runs a statement. Inserting uses those question marks as placeholders. You pass the actual values as extra arguments, and the library fills them in. 3 notes in, and SQLite last insert ID tells us the ID of the last one, 3. We never had to write the IDs ourselves. The primary key counts up for us. sqlite-query gives you back a list of rows, and notice each row is a vector, not an A-list this time. #paren, then the column values in order, so vector-ref with index 1 gets you the title. And the filtering happens in SQL. Ask for the ones where done is 0, and you get just the 2 pending notes. Here's why those question marks matter. This is the classic SQL injection attack, a string designed to end the query early and drop your table. Watch what happens. Nothing. It came back with no rows, because the library treated that whole thing as an ordinary piece of text to search for, not as SQL. Count the rows, still 3. The table's fine. If you'd glued that string into your query with string append, you'd have lost the table. So, always use the placeholders. Never build SQL by concatenating strings. Updating is the same pattern. A statement with a placeholder. Coffee's bought, so mark it done, and there it is, flipped to 1. And anything SQL can compute, you can ask for. Count comes back as a single row with a single column. So we reach in with car and vector-ref to get the number 3. And here's the whole reason we're doing this. The program has ended. There's notes.db sitting on disk, 8 kilobytes. Run a completely different script that just opens it and selects, and everything's still there, exactly as we left it. That's data that outlives the program. When several changes have to happen together, wrap them in a transaction. Everything inside either lands as a group, or, if something raises an error partway through, none of it does. The database rolls back to how it was. It's the Dynamic Wind guarantee from Season 1, applied to your data. Note the function here takes no arguments. You keep using the DB you already have. One last move that ties the season together. Rows come back as vectors, but our JSON library speaks alists. So map each row into an A-list, and now you can hand it straight to JSON write string and serve it from the web server we built last episode. Database to JSON to HTTP, and the glue is a single map. SQLite gives you a real database in a single file. sqlite-exec to change things, sqlite-query to ask questions, placeholders to stay safe, and transactions when changes have to stick together. Next time, we tidy all of this into a proper project with Thoughtum, Kaappi's package manager. Thanks for watching. Subscribe for more Kaappi.